And we are live. Welcome everybody to today's webinar. We'll give this a few more minutes before we start. Feel free to familiarize yourself with the functionality in Zoom. We have a chat where you can say hi. Feel free to say hi. We have a Q&A section. So if you have questions in between or afterwards, just feel free to post them in the Q&A section. That way they're easier to track than if you just put them in the chat. This session is being recorded and you will get a link to the recording tomorrow. And we will also share the slides afterwards in an email tomorrow. Okay, I see the first people saying hi. Hi, Aaron.
Hello.
Welcome. We'll give this 2 or 3 more minutes before we get started to allow people to join. Hey, Boone. Hey, from Dublin. Nice. Galo, I think you're in Barcelona, right?
Yes, I'm in Barcelona.
Cool. Great. I'm in Germany, so this is I think we're all very used to that by now from all the video calls and remote work we are doing. Buenos Aires, nice. Hey, Kevin, welcome. So maybe just repeating what I said in the beginning, for those who joined a bit later, welcome. This meeting is being recorded. You'll get a link to the recording tomorrow. We do have a chat and some of you already found that to say hi. I like that. We also have a Q&A section. So if you have questions during Galo's presentation or afterwards, just feel free to put them in there. I will monitor this and I'll either interrupt you, Galo, if the questions make sense in between, or we'll keep them to the end. Let me just start a poll because these remote presentations always have the challenge that neither Galo nor I can really see the participants, so it's very hard to get a feeling for the audience. So we have a very small poll just to get an idea of who you are. So if you like, it would be helpful if you could answer this short questionnaire. Which of the following titles describes your current role best? And we only have a selection, so it's also okay to say none of the above. We're expecting that, but that way we have a bit of a feeling of the audience tonight. All right, and I would say with 3 minutes in, let's get started. So welcome again, everybody. I'm Christoph. I'm CEO and co-founder of Humanitech, and at Humanitech, we are building a solution for developer teams to build their own internal developer platform. So we are all about internal developer platforms, but that's not the topic for tonight. I'm very happy to have Galo Navarro with me today. He had the task of building an internal PaaS for 1,500 engineers, and I find this a great task and a great story that you tell. I already heard it once, so I'm really looking forward to hearing it again. So I'll hand over to you, Galo, to introduce yourself. Then I'll share the results of the poll, and then you can get started.
Okay. Hello, everybody. So, yep, I'm there. So, yeah, I'm Galo. I'm currently working as a principal software engineer at Relic for a year approximately. Before that, I was working at Adevinta, and basically the topic of this presentation is the work that I was doing in there. And yeah, I have previous positions as generally as backend engineer, systems engineers, in different companies of different shapes. You can find me in LinkedIn or the usual places. Sorry.
Cool. Yeah. Welcome again. So let me just share the results from our poll. So this is our audience tonight. We have most of the people attending are either DevOps engineers, SREs, or engineers. We have 2 students, 1 CTO, a few engineering managers, and then some where we just couldn't make up the right categories. So none of the above. That's just for you to have an understanding of the audience.
Sure.
And with that, I'd say let us know how you went ahead and built an internal platform for 1,500 engineers.
Okay, so I'll go ahead. Basically, the whole topic of the talk is technical infrastructure, which is what you mentioned about humanitech. So this is a term I took from Will Larson. You have the link to his blog at the bottom. And he describes that as the software and the systems that engineers use to create, evolve, and operate their businesses. Okay, so that's basically, it includes pretty much anything that you can think of. So it's from cloud services like AWS or Azure to your typical CI/CD platforms. It can be data infrastructure, whatever else. Normally, every company, when they reach a certain size, they dedicate a team that is focused on this type of tools. And every company is different in that in some cases they focus on developer tools, maybe in other cases they focus on the data infrastructure, in other cases they focus on everything, etc. But in general, that structure is common, that there is one team that is not really building a product. What they are doing is building tools and infrastructure that all the other developers use to deliver their work. Okay, and that's basically the topic. So I have a couple of friends that also work in this space. So I was asking one of them for a picture of his company, like the area where his team works. And this is a real picture. This is what he sent me. And I found that very, very interesting because you can take individual vignettes and they show some of the specific problems that we suffer in this space. So one of the very common ones is you are supporting a lot of build tools and they are all deprecated or 90% of them, but your product teams are still using them. So you kind of have to support them. It's expected of you. You have to support internal libraries and you're in the same problem. You have to support all of them because the product teams use them and the product will not work without them. They also don't have the time to upgrade them. So you have to support all of them. They are incompatible, transitive dependencies, hell, etc. There's the never-ending topic about languages. So every engineer has a preference, every team has a preference, and they just can't agree with each other. So again, you have to support all the possible languages and all the possible dialects of every language, simply because engineers, that's what they want. In the middle of all of this, you have the last three releases may not have been very smooth. You may have hired a release manager to try to put some order in the situation, and it doesn't quite work as expected. Then the CTO may come and have fantastic ideas about the strategy. So, for example, we may not be doing microservices properly, and that's the root of every problem in the company. And okay, he wants to migrate to containers, and you as a platform team have to help in this. So you have to herd everybody in the company to move to containers. And as you can see, it's not a very pretty picture. The CTO is here on the horse. So the problem we had at Adevinta, and I mentioned that before, but I'm not working there, but this is the topic when I was working in Adevinta. So what happens if you multiply this problem by 20? So it's not only one company that you have to support, but you have to support 20 companies doing this thing. That's, oh, sorry. Yeah. So that's more or less the problem that we had at Adevinta. So Adevinta is a conglomerate of different companies. It has a lot of marketplaces in Europe and South America, especially, and they operate as completely independent companies. So what that meant for us, which were a central team that was tasked with supporting all of those companies in the space of technical infrastructure, is that we end up having 20 different companies, 20 different cocktails of technologies, of cultures. Everybody has their own scar tissue about which things work and which don't, etc., etc. And in many cases, they had their own platform team. Okay, so that's a balance. Yeah. So that's pretty much how Adevinta looks. Okay. So yeah, if Adevinta, conceptually, you can think of it as Adevinta is building online marketplaces, and what we were trying to do is enable everybody to build every sub company inside to build their own marketplace um, in a way that reduces a lot of the technical infrastructure because. Of course, you don't need to have 20 different plumbing systems to build 20 different marketplaces. You can reuse the same plumbing system. Okay, that was what my former team did, and they still do. I'm just not there anymore. So what I'm going to talk about in this presentation is especially about some strategies and some mindset maybe that we used to be successful in this task that I hopefully showed before is not very easy. So one question I usually make, I can't see your answers, but I'm going to assume them. I guess you know who these people are, right? They are, and what calls my attention here is this is how fiction represents a profit center. A profit center is a part of the company that brings money in the company, okay? And what I like about the image is that you can see that fiction represents this in a very particular way. Like these people smell of money, all of them, okay? And it is for a reason. It is because they bring money in the company. Whereas you probably also know who these people are. These guys don't smell of money, right? And that's because these guys are a cost center. And a cost center is a part of the company from which money exits the company. They are not bringing a single dollar in the company. They are spending them. They spend them for a very, very good reason because they have to build computers. They have to make them work. And that's what enables other people to make money for the company. But they themselves, they don't produce any value, okay? And I think this is a very important point for me for platform teams, that having awareness of this distinction, that you are not, when you're working in this space, you're not a profit center, you are a cost center. And that's a tough position to be because in general, every company or the financial department of every company is going to be looking very closely at every cost center, trying to cut it and externalize it, okay? You don't have people growing coffee beans in your company because that function has been externalized. Okay, so there's no point in paying people to grow coffee beans. So this is the same problem. Like everybody's going to be looking at you saying, okay, can we replace this team that is doing technical infrastructure? And in the past, yeah, so this is what I mentioned. In the past few years, maybe the last 5-10 years, there has been a lot of competition appearing outside of every company. Okay, so 20 years ago, the people that did technical infrastructure were very respected because if they went away, the company exploded. Nobody can manage the servers, nobody can configure them, etc. But today, that's not true. You can go to the market and you find a lot of providers that can give you technical infrastructure, and it just works. Okay, so this is something super important, I think, when you're working in platform, that this is the people that you're competing with. You have a team of maybe 10, 50 people in the biggest case, and you are competing with huge companies with thousands of developers, not only one, but many, okay? So it's very likely that you lose that battle. You have to be very clever in how you operate. These people are also contributing, but also there's a whole community, open source community, that is producing tools and services that do exactly the same things that you're meant to do. Okay, and this is the CNCF landscape. We were joking before that this is from 2019, and so this is even more complicated now. Okay, so what do? You have a team of 10 people. You're competing with the entire industry. I remember the first time we did this presentation. It was the day after the AWS reInvent, okay, in Vegas, of all places. And one of the things that they announced in that presentation was, in that conference, was quantum computer as a service. Okay, so this is every time that these people announce a feature or they announce a product, this is pretty much what you see. Okay, that was reInvent. It was something impressive. It was even before the pandemic, so people was there. So you have your team of 10 people. You have been doing a lot of work. This is great people. They are all very committed, very good ideas. But when you do your demo, your monthly demo, your quarterly demo, it sort of looks like that, because what do you have? You don't really have the gunpowder to compete with AWS. They are bringing a quantum computer as a service, and you're bringing a CI system. You have installed Jenkins. It's a losing battle. So this is, I think, a super important point. Like, you are a cost center, you are competing with commercial companies, many of them very, very strong, very, very fast. So you really have to pay a lot of attention on making sure that the value that you're providing, which you are, is visible, it's relevant, and it's measurable. Because otherwise, you are going to get cut in the next reorg. If not the next one, two from now. Okay. So yeah, as I mentioned, what are some of the strategies that we had? So one is having an actual product. This is, I think, something important that changed in the last few years. Like, this is no longer about building a set of tools and you just throw them to the engineers and that's it. Okay. So what did we do? How did we approach this? What we said was, okay, we're going to build a product that tries to help developers on the entire development cycle. You have probably seen this graph. So developers are coding, planning, measuring, operating, yada, yada. So we are going to give them tools to help them in this journey. And we would go to those teams, to the CEOs, the managers, etc., and we would give them this speech that I'm about to give you. So we would tell you, look, we are here. We understand that you are working in a very, very competitive space. You are building a product. This product has a lot of competitors. In the case of Adevinta, that was Facebook Marketplaces, eBay, etc. And that's a very tough job. Now, you have two options. You can build the car yourself. You can build all this technical infrastructure that you need to build these products. You can do it on your own. That's fine. We don't have a problem with that. If that's what you want, fantastic. If you want, however, we can actually do the heavy lifting for you, so that you don't need to focus on the wheels, the engines, the gas, etc. We do that for you, and you sit on your car and you focus on winning that race. Okay, winning the race against our competitors in the market, and not building CI systems. Okay, even if it's interesting, but it's not your job as a product team, and you choose. The tools that we gave them, we followed an approach that is, some people call it the golden path. I didn't put the link, but if you look for Charity Majors, she's more or less well known in Twitter and other places. She has a post about this. She goes more in detail. But the golden path is simply trying to make it very, very easy to go to follow up a specific path that we think is good. Okay. For us, the development process would look something like that. So we would give a number of tools that do the job of, you take code from GitHub and you can put it in production. Most of these tools are open source. Actually, I think all of them or publicly known. So you put code in GitHub, goes to Travis, then Spinnaker deploys, Kubernetes, etc. And we chose those tools not because they are the best, but for two reasons. One, because they were already in the company and they were prevalent in the company, so that was the path of least resistance for people, or because they may not be the best, but they do the job. So I don't know, Kubernetes may not be the optimal choice, or Spinnaker, but it does the job. So we give you sane default choices that are proven. And the problem is that you can't stay there. You can't just say people, okay, here we have a number of tools, we have deployed them for you, we made them available, and now you assemble them together in every single one of your projects and deploy with them. Because that's basically an IKEA-like experience, so that this is not what you do with a Formula One car. Okay, that doesn't work as for that metaphor. So the focus in there is that the value that we provide is not really in which tools have we chosen as sane defaults. It's more in the glue, in how have we connected and articulated all of those pieces so that they work together on one side, and you as an engineering team, you don't need to worry about wiring them together. Okay. So we do that for you. That's the value that we give you. And that's the point that I would like to stress, that in general, good integrations are about facilitating changes and providing escape hatches. What does that mean? The integrations that we did would allow teams to take one of those pieces and remove it. So for example, they could say, I don't like Travis, I want to have Jenkins, and they were going to deploy Jenkins on their own. So we would allow them to plug it in that golden path. Okay, so they have an escape hatch, and they can change, they can replace different pieces if they want to, but they don't need to. That's the point. Another point, another strategy is when we make impact, try to make it very small, but make it often. Sometimes this is a mistake we have done, and I think a lot of people do, is they try to do something very, very big and very ambitious that is going to have a lot of impact straight away. The problem is that it's going to take you seven years. Those 7 years are going to have 7 reorgs on average. And in one of those reorgs, the team is going to get cut. So you're never going to get there. Okay? So we try to do the opposite approach, which is, okay, let's provide value by the end of the month. One example of how we did that is the following. So what is here is a very bad graph of more or less all the actions that you take when you prepare a code change and you get it you merge it, okay? So you submit a pull request, you have to assign reviewers, there has to be a pull request review, there has to be an execution in Travis or your CI system, then the quality checks, then maybe somebody else merges another PR, so you have to update the branch, and then you merge it, okay? So this has to happen a number of times. We noticed that there are only 2 steps in here that require human brains, okay, which are writing the actual code and sending the pull request, and the other one is making a review. So what we did was all of the other steps, all of the other tasks that are involved in submitting code, in putting code in production, we automated them one by one. So we started, I can't remember, I think it was the quality checks. So we started putting automation. This unicorn is Skynet. That was our pet. So we started building individual bots that would automate one of these stages, one by one. Okay, so those were low-value activities, but you didn't need to do it as an engineer. At the end of the year, or after some time, what you have is that these things accumulate. So I took this last year when I was doing the presentation, and this is the bot that did all of these actions in GitHub. So it had 90,000 contributions in that year. So you can just add the numbers. If you assume that each of those tasks is saving 1 minute only, and some of those tasks are well over 1 minute, but let's assume a conservative estimate, we have 187 working days saved per year. Okay, that's simple arithmetics. So basically, this was the most productive engineer in the company. And you can very easily go to anybody and say, okay, what is your team doing? Well, I'm creating engineers, because the work that this automation that we did is effectively as if we have hired an extra engineer. Okay. One alert that you should have on your heads is, I said before that you should really not be competing with AWS, GitHub, etc. All of these external companies that are doing tools, they are doing exactly the same thing as you, and they are selling them on the market. So what I described is automation that you can apply on pull requests and so on, and there is GitHub Actions. This actually appeared a couple of months before the presentation last year. And it is precisely the same idea. So you have code in GitHub, and what GitHub Actions give you is a very easy way for taking these things that happen in GitHub, and then you can react to them and you can apply automation. You can build very powerful automation. 2 points about this. One is, for us, when this appeared, there's some people that panic in the team because they say, okay, we are building very similar things. So what is the point of us being here? We're going to get fired, or we are going to be reallocated to another team, because there's no point. GitHub has taken our jobs. there's a good part in that, which is the validation. Like GitHub noticed that there's a need in the market that we had seen maybe 1 or 2 years before. But yeah, it's true that there's some panic. How can we protect ourselves against this? Well, if you realize when GitHub Actions brings that feature, they are building something that is specific to GitHub. Okay, and that's, I think, the mistake. If you are doing something that only works with GitHub, then you're going to be replaced by GitHub at some point because they will produce that feature. But what we had built was not a tool that was specific to GitHub. It was not actions. It was not automation based on GitHub actions. It was automation based, oh, sorry. There. I shouldn't touch the mouse. It was automation that was built for all of the systems that Adevinta had in their internal platform. So we were able to react to things that were happening in Jira, in Spinnaker, in Kubernetes, anywhere, okay? And that protects us from being replaced by GitHub because GitHub is not able to integrate with Spinnaker, GitHub Actions, nor with Jira, nor with Slack, etc. Okay, so our job is safe, our platform is safe. The way that we did that is it's a very simple system that it's basically an event bus. So what we did is connect the generally this is webhooks, but sometimes it's a different thing. And we collected events from all of those systems. We put them all in an event bus and we kept them in a log. So after a few years, we actually had a log of everything that had happened in GitHub, everything that had happened in Travis, every build in the company, we had a log of it. We could inspect it. Every artifact that was deployed, we had it in there, okay? And we could advertise that in an event bus. So we could very easily build automation. One example of that automation, well, somebody said, it's a pain because some pods are dying and I don't know why. So it's very easy for us to build a very simple bot that reacts to a Kubernetes event and writes a message to Slack. Okay, so all those arrows, as I mentioned before, we are not building Kubernetes. We are not building the event bus because we were using SQS. What we are building is the ability for you to listen to events that happen in the ecosystem, whatever they are, and to react against that ecosystem, send a message to the team, whatever they are, in Slack in this case. Okay, this took a very short to implement. So yeah, this is my main point, that we are not offering tools. Tools are something that a commercial company can come and replace. We build an ecosystem. An ecosystem is much harder to replace. And our ecosystem is tailored to Adevinta. Implicit in this, another strategy is to try and build virtuous feedback loops. This is network effect. The more population you get, the more value you generate. So I was explaining just now, we had all of these tools. We were collecting events, things that happened in this ecosystem. So the natural step from there is, okay, can we build analytics on all of that? The system that I'm showing here, this is a very old UI. I'm sure it's better now. But what it does, and you can see this in the on the right, so in the pie charts or wherever they are, you can see a list of Kubernetes, Spinnaker, GitHub, yada, yada. Okay, so you have a lot of all of those events. It was producing analytics. This was very, very powerful because at the end of the day, having all that data enabled us to build instrumentation for the development process. And this is what this tool Ledger was. So what we could explore was, okay, let's see how many deployments we have. Let's see how many builds we have. Let's see how long they take. Which are the teams that have more builds or less builds, how long they take, etc. This was super useful when you want to have conversations with teams and sometimes influence their behavior, which, as I showed at the beginning, it's very, very hard to go to engineers and influence their behavior and tell them, maybe you should be doing smaller PRs because, I mean, that's a good development practice. That's part of our scope, pushing good development practices. Make your PRs smaller. And they will tell you no, they will think that you're stepping on their toes and so on and so forth. We never did that. What we did was, this is out of order. Show them something like that. We didn't bring any opinions. We would go and tell them, give them this chart for their team specifically. These are all the projects that you have in your team. So the two charts are, the first one is pull request by size. So you have, each bar is lines of code. So you have from 0 to 24 lines of code, from 25 to 49, etc. And the height is the number of pull requests. So this team in particular, they had a lot of very small pull requests, 0 to 24, and different number of bigger ones. And the graph that was at the bottom was the time to merge, the 75 percentile of the time to merge that PR. And the scale is the same. So you have 0 to 24 lines of code on the left, and you have the amount of days that it took to merge this PR. So you can see that very small PRs took very little to merge. The moment that you double the size of the PR, it almost goes to a day. And when you keep making the PRs bigger, it takes 2 days, 5 days, and so on. So I don't need to explain to people and to convince them that making small PRs is better. But that's in the data, I think. You can give this to them and they are going to come up with the same conclusion without you having this friction, okay? And there are very interesting bits, like the one I loved about this chart is you can see that the last bar, the time to merge the largest PRs is smaller. And everybody would laugh at this and they would see why it is. Because when you have a threshold, a particular threshold, teams stop reviewing code. So you are merging things that you haven't really reviewed because they are too large, okay? And they would make this conclusion on their own. You wouldn't have to convince them, okay? So all of the type of metrics that we displayed are things that we took from industry research. One of those places was this Accelerate book, which you have a link in there, also to the State of DevOps report. So these are external companies that are doing studies across the entire industry, and they're coming up with which are the metrics that tell you if an engineering team is efficient or not, if they are productive or not. So again, we don't really bring an opinion, we as a platform team. What we do is, look, the industry, there are books, there are academic studies that are saying these are the 4 metrics that you should really be measuring and optimizing. So we have instrumentation on our development platform. We can tell you what these numbers are for your team, for your company, for whatever you want, slicing and dicing by whatever dimension. And here they are. You can take whatever decisions you want. This is very good because, one, it removes the friction for you. You're not fighting to make the point on whether lead time for change is good or bad. The industry is doing that for you. And the second is that there's a virtuous feedback loop, because if you are using our platform, then you are going to get these numbers. And that's an important point because CEOs, executive types, are the type of people that are reading these books. So if you tell a CEO or a CTO, I can produce these numbers for you, for your engineering team, they are going to push for that team to adopt your tools, because then they will get these metrics, okay? From what I know in Adevinta in the last year, this has been the case. Like there's pressure from the executive teams and managers to, okay, we want to see these numbers, okay? So yeah, this is what I explained. Like you're influencing things in a way that doesn't force you to confront engineers, to alienate from them and so on, which you don't want because you need them to trust you and to like your team. And I think this is not only about influencing engineers or having them do whatever you want. It's also helping the individual engineering teams, because this is a problem we all have as engineers. You see that you have refactor to do. There's a lot of technical debt, whatever. You think you need to rewrite everything in Haskell, and you don't get time to do it. You don't get budget. And we always go to the managers, to the executives, and we tell them, oh, the company is doomed. We need to focus on technical debt, clean code, blah, blah, blah. And the executive teams, the profit centers, they just don't understand it. And they shouldn't understand it. It's not their problem. So they are going to tell you no, because you're asking them for God knows what, to spend time on engineering, and they don't care. So when you have these type of metrics, the conversation is completely different, because you can go to them and you tell them, look, you went to this executive conference, and in this executive conference, they were talking about the Accelerate book. And the Accelerate book has 4 metrics, and they tell you that they are very good and you believe in them. So here they are for my team, and they are going down. And you can trust that this has a correlation to there's worse value, the product is going worse, and so on and so forth. And at that point, you can very easily make a case for give me time so that we can fix it. And notice that you're not talking about, we want to rewrite in Haskell, we want to rewrite as microservices. You're talking about, we want to improve the deployment time. And they don't care. You will achieve that because you go to containers, but they don't care, okay? So that's part of what the value of the PaaS, that we were trying to help also engineers to articulate that conversation with the profit centers. Invest in a component. So I said before that building your own tool is generally not a good idea. Sometimes it is. So this is an example of when that happens. So one of the things that Adevinta had, our platform, is a Kubernetes cluster that we assembled. So we didn't use EKS or GKE. It was our own cluster running on EC2. So why did we do that? So in Kubernetes, this is pretty much what you get with a stock Kubernetes. You install the basic components, you have an API, and you can run containers in there, and that's pretty much it. This is what our Kubernetes cluster had. So I'm not going to go through all of the tools. You probably know some of them, but we had an autoscaler, we had security policies, we had configured all the networking inside and outside to connect outside our network. We had exporters for that, Adobe for Prometheus, for Fluentd, etc. We had ingress controllers, cert managers, and so on and so forth. The authentication connected to Adevinta's authentication system, so people could use Okta to log in the cluster and so on. So this is what we provide. We don't provide Kubernetes. We provide a Kubernetes that is ready to use in production by a large company that has very, very big requirements about things. Okay. We gave them dedicated on-call. This is, in theory, something that AWS provides and Google and so on, but you probably know that it's not as rosy as it looks. Here in Google or in AWS, you have a team that is dedicated to on-call, but they are dedicated to on-call for all of their customers. In this case, you had a team that is dedicated to you. So we are going to pay a lot of more attention. We have a faster reaction time and so on. We can also interact with the AWS engineers when needed. We provided multi-tenancy, so we could isolate one company from the other or one team from the other, which is something that is not available in Kubernetes by default. This is very important. So when we updated the cluster, when we upgraded the Kubernetes version, if you go to GKE, and yes, it is true that you can click on a button and it upgrades the cluster. So you go from version A to version B. The problem is that Google doesn't really care whether everything that you have running in the cluster still works in the new version. And you have a lot of things running in the cluster, as I showed before. So the other thing that we did is, well, we are going to do Kubernetes upgrades, but also we are going to take care that everything inside works. Possibly also your applications. If your applications break, you're going to have us here. So we are going to help you. And we are not going to make an upgrade that breaks half of the applications in Adevinta, just because. And yeah, we had the multi-region support, so you could deploy one application, multiple regions. This was something we were working on last year. Another thing we had was pre-built operational dashboards. This is a terrible example because it's super boring, but yeah. When you deploy in our cluster, you automatically have, this was Grafana, so you have metrics about your pods and so on. And this is the one I like more. So something that was very important to argue for why should people move to Kubernetes, which is a question that I think everybody should make before they do it. One of the key arguments was, well, this is going to be cheaper because we are going to make better utilization of resources. So we said, okay, if we are going to be pushing people to move, we should really give these numbers. We should be measure our impact. So every team, when you started deploying in Kubernetes, they will get a dashboard where we would tell them, look, this is how much money you are spending at a very, very tight granularity. So we could actually go by pod. So we could tell you how much it costs per month to run one pod of this application, okay? And we can tell you this is being efficient or not efficient because your utilization is high or low and so on. Yeah, as I mentioned, we can go we could go to a very, very low detail. And this was also very useful for them because, again, sometimes teams wanted to move to Kubernetes, but the executive team didn't want them to spend time on with Kubernetes. The moment that you can bring examples that, look, that team in front of us moved to Kubernetes and then the infrastructure build was cut in half, then they are actually going to get more support. Okay. And very important point, almost finally, is the zero friction onboarding. This is, I think, a systemic problem in all the PaaS, internal PaaS that are built across the world. And it has been a historical problem for all the infrastructure teams. And I think it's one of the distinctions that kills these teams versus commercial competitors, because a very good example is Heroku. You can get things deployed in Heroku in 5 minutes, and it is a pleasant experience. Normally, the tools that internal infrastructure teams give you are, let's say, rough. So they are script, or you have to wire things on your own. Okay, and it may be that the tool is very good, but the experience that you are giving users is really not very good. It's painful, and they can today they can look in the market and they can see something that is pleasant. So you're going to lose people. So one of the things that we invested on was, and I want to make a point here, we invested by taking some part of our headcount, and we removed the positions that were hiring engineers, and we started hiring product managers. We started hiring UX designers. Okay, that's what I mean by invest. So we put people that knew about designing user interfaces to design a user interface. How is our customers or how are our users interacting with the tool? This is the first version that we did of the onboarding tool. So they would go to this page, which was internal, and they could click on that button to get started. They could enter the repository URL in there. We found actually, so it was a fuzzy search. And at that point, you enter the repository there, you click on a button, and then all the automation starts kicking in, and we would set up that repository automatically. So it runs, it runs with continuous integration. It has continuous delivery. So these are the things that deploy to Kubernetes. We would set up the observability tools that we have in Adevinta, and so on and so forth. This would happen in a few minutes, and you would get the green balls. And at some point, they would say, "Okay, you're done. You can click on this button, and you would have an opportunity to do the last review before these things actually get deployed." So no need for writing scripts. No need for reading a huge book of instructions. You do the same thing that you do in Heroku, which is click buttons, click one button. Important thing, we would give people support and we would give them a help center. These are a lot of tools, but you can go to a single place and you have the documentation for all of these tools in the same place. You have the access to the same support. You have access to documentation that is homogeneous and common to all of these things, as opposed to, yeah, we integrate these 70 different tools. You can just Google for each of them if you have a problem. Okay, and even though we had a lot of, we had like 4 or 5 teams that were managing subsets of all of this tool set, one of the things that we did is have the same response SLA for all of our teams. Okay, so for our users, it was not confusing. They would know that if you're using a tool in the past, you have the same support, the same conditions, the same SLAs, and so on. You're not putting the burden on the users, you're putting it on your team. One of the final closing remarks is that change hurts still. So when you're in this type of team, you want to make things easy, but at the same time, it's frustrating because the teams have to change and they have to adopt your tools. It is a very grueling process, and But one of the things that you have to do is understand that for them, it is even worse. Like they are stopping product development and still have the product managers and the managers on their toes, asking them to deliver things faster. So for them, this is a distraction. So you have to be there, on the same boat with them. Sometimes the experience is not very good. This is an actual example of one of those migrations. But I think that the experience pays off in two ways that are very important. One is that you experience what it is to use your tools. So you can get that information and you can use that to improve them. And you discover a lot of very interesting things. The other is that you earn trust with those teams. So after you have been working with them in adopting your tools, they see that you are there to help. And the next time that you come and make a suggestion or tell them maybe you should be using this, or they have a question about something, they are going to come to you and they are going to trust what you say. So again, if you want to influence teams, the most efficient way is not entering fights with them, not trying to push them in any direction. You give them information, you let them make their own decisions, and you earn their trust. And this is one of the best ways to do that. And yeah, so part of what we did was on-site hands-on support for migration. So we would fly people to the Italy office, and they would be there for 2 weeks, helping them adopt our stuff. Or I mentioned. So is this work or what is working? So this is from last year. I think this is a lot better now. But our North Star was the number of deployments per week, and we could see that over the year it kept growing. So that was showing that we were influencing the right things in the company. And this was a message that one of the engineers in Adevinta Spain put in Twitter without us telling him anything. I will translate for if you don't speak Spanish, but he said that the transition to Kubernetes was going so well that he's not noticing anything. Everything works perfectly, and hat tip for everybody who did it. So this is the type of experience that you want. And if we were a commercial company, this is what you want. This is what Heroku wants, that people is talking in Twitter about their platform. So this was one of the things that we were trying to achieve. And it was very nice to see that some of the people that used it were happy about it. And yep, that was fun. Q&A, and thanks a lot for listening.
Galo, thank you so much. I know we overran a bit in time, but I didn't want to stop you. It's so great to listen to that story. Thanks. We do have a few questions. I'm happy to read them out, but I would be also happy to unmute the people that asked. So if you want me to unmute and you ask the question yourself, just raise your hand. And then I'm happy to do that. Otherwise, I go through this. So we have one question from Kevin. How long did it take to get the Adevinta ecosystem to the point you showed? How many people were working on the team?
So this was a work in process. So we were in the process of migrating some of the marketplaces. I think yeah, and so it wasn't finished. Okay, so we still had a lot to do. I think the team that was working on the PaaS was created from smaller teams that were working on these tools. So one of the things that happened in Adevinta was that we realized that having independent teams that did chunks of all the platform didn't work, and we needed one team that built all of these things together, an ecosystem. So when we put together all the people, I think it was like 30 people working on this space. And okay. Yeah, it depends. The migration would depend. So small marketplaces with a few hundred engineers, 100 or 200 engineers, could take a few weeks, maybe to migrate them, a couple of months. Others, I know it took a year for the bigger ones.
Cool, great, thanks. So let me jump to the first questions in a row. Aaron is asking, is there a story around reduced operational toil that can be articulated? So. Is this something you also focused on?
Yes, many of these, I would say, yes, it is completely about operational toil. The problem is that it is very hard to articulate what the hell is operational toil. And in many cases, the engineering teams themselves don't even know that they have operational toil. So you can have teams that are spending half of their time taking care about builds, and they don't notice that that is pathologic. Okay. So one of the things that we would give is the teams that knew, or the managers that knew that this is a problem, they could come to us and they knew that we were giving a platform that helps you reduce operational toil. The other effect is that the teams that were not aware of this, they would see that there are differences. Like, okay, that team there is very happy. They don't spend half of their time doing builds. Why is that? And they would ask, and that would encourage adoption.
That's the way you use data. I really like that part, to provide data instead of recommendations to teams. I think that's very, very strong. One question that Costis has is regarding your cost analysis that you showed. Is this an approximation, or do you actually use the API of the cloud provider to calculate precise numbers?
It was an approximation that we kept refining over time, but I'll go back to my point about the iterations, the small impact. So day one, it is better if you tell, look, we are paying for this Kubernetes cluster. We pay this much because we have the numbers from the account, and we divide by the number of pods. Let's say this is a bad approximation, but it's better than nothing. And we kept refining from there. So I think at the point that I took that slide, it was reasonably good. And we were aggregating numbers from many places. At some point, we also started, the numbers that we would give to executives would also incorporate the money that was spent in salaries for the people working in the team, because that also should count.
Yeah, absolutely. Great. I think I like the start simple and then enhance over time idea behind it. Yoko is asking, how does your team decide what to build versus what to buy? Obviously, you can't build everything or buy everything. So I'm curious about your decision process.
So normally it's buy by default. And we never build. We only build integrations and glue between things. And in some cases, you land in the situation that there's nothing to buy. Like you really can't find the tool. It is very, very odd that happens. So at that point, you buy. In some cases, it is that, okay, something exists, but we can't really use it because it's missing this feature. Spinnaker, for example, is one case where we actually contributed a lot of code. So we also went that route, that we became contributors to some tools.
Okay, so but your default decision was always buy if it exists, because you don't want to compete. That goes back to your first point, right?
Exactly.
Okay. Yeah.
In some cases, we inherited something that had been built in the past, and we just continued it because it didn't make any sense to delete it.
Sure. Okay, understood. So Aaron has a second question. So also there's something to the idea of systems like this helping people to reduce accidental differences between how services run. Or moreover, like you mentioned, having some standardization to things, like let's change to RIs on demand. Can't be rolled out fleet-wide if everyone runs the same set of 4 to 5 things.
Yeah, so I think it is true that happens. There's a lot of accidental differences, and the containers case is very good. Containers, actually the Docker ones or the computational ones, because what happens is that at some point people think that the things that are specific to them or the specific way in which they do something is justified. It is there for a reason. It cannot be changed. And there's a process by which the industry convinces them that it doesn't really happen. For example, the fact that we SSH into a server, it was completely natural 15 years ago. If you told somebody you should not SSH in the container, the world would fall apart. What they realize very slowly is that that's not the case. The containers are the same. You don't need to have every possible shape of containers on the image that we have in front. You can have one shape and it just works for everybody. But making people realize about that is not an intellectual process. You cannot talk them into accepting that. So that's something I realized at some point, and I gave up explaining. So, I mean, what happened? Why do people accept the same size of containers? Because otherwise you cannot use the global logistics systems. Yeah. And that's too bad for you. So reality forces that.
Yeah, that's a very nice approach to it. Second question from Costis: do you think that the Accelerate book is sometimes misused? Everybody can understand deployment frequency and lead time, but to all agree on what change failure rate is? What we define as failure might be different between orgs. For example, if deployment of an eShop is successful for users, is successful, but users cannot buy something because the payment gateway doesn't work, is that a failure or not?
Yeah, so that metric in particular, was the most problematic to implement. So we didn't at the beginning. Deployment is much easier, although even deployment is complicated for the same reason. Like, what is a deployment? Like you put something in production, or you put it in production and you don't roll it back in the next 5 minutes, etc. What we did there is, okay, you define what is a successful deployment for you. So when you send the event that there has been a deployment, there has been a failure, it is you who decides what defines a success. And what we provide is what I said. We give you Glue. We give you an API that says, please report how many deploys, how many errors, how many so on and so forth. We crunch the numbers and so on. But we are still flexible so that we can change the definition.
And the team can change the definition. I think that's the important point in there. Yes.
A simple example of this is the builds. So if you have a build in Travis or you have a build in Jenkins, both of them are going to produce an event, and you can tell us what that event is. You emit a deploy event or a build event and so on.
Yeah.
So we did it in that way. There's a normalization layer.
Great, understood. So one question from there: do teams still have total autonomy for hosting decisions? What's the level of uptake on the platform, and what's the usage of escape hatches like?
So the autonomy for hosting decisions, that varies. Like, there were some companies in Adevinta that the CTO would say, no, we have to use AWS, or we have to use this, and then everybody would do that. Other companies prefer to be more autonomous, and they would let any engineer choose. It varies. I think that there was an average in some direction, but not a lot of enforcement. The usage of escape hatches, Jenkins was an example. So you have Travis. Some people didn't want to use Travis, so they put a Jenkins that they maintained. And we gave them a couple of tools so that when the build finishes in Jenkins, they send us an event. So that way it integrates in the rest of the ecosystem. I'm not sure about the level of uptake.
Yeah, I mean, how many? What's the level of uptake? I read this as how many people that actually decide to use your platform rather than doing things on their own.
Oh, so I think maybe half, I would say, of Adevinta was on that, and the other half was, most of them was in plans to migrate, but for reasons such as not having time, it was sort of in the roadmap. So
yeah. But I think that's also an important approach, like a bit of a grassroots approach to move, go team by team and see who's interested. And then because you can't force anybody in this, obviously. Cool. So one last question, and then we close this. I know we're running over time, and I see people dropping out, but that's fine. I still want all the questions to be answered. So the last question comes from Kumar. And he asks, was your team focused on common functional blocks also that can speed up things that you do across products, or was it limited only to tools and infrastructure?
No, so in our case, there's a part in Adevinta which was the central functions, and we were part of that, taking care of infrastructure. There were other teams that were doing this kind of work. So, I don't know, functionality for messaging.
Shared services.
Yeah.
Okay, cool. But your team focused on the infrastructure and tooling thing.
Exactly.
Cool. So with that, we've answered all the questions, or you answered them. Thank you so much again, guys. That was a great presentation.
Thank you.
I was expecting that, but it was still great fun to see it again. As I said, we're recording, and we'll also send out some of here if you want to get tomorrow. Even buddy. Thank you.
Thank you. Bye. Thank you.